Welcome everyone to this latest Zero Carbon Mine webinar. Today we've got Lex from Janus Electric talking about the electric battery swap trucks. Zero Carbon Mine, we're really about just facilitating discussions about decarbonising mining industry and all the related aspects that go with that. So if you've got any questions, raise your hand and we'll see if Lex can get to them as we go through. But other than that, we'll wait to the end and have a bit of Q&A at the end. But hand it over to Lex to get the ball rolling.
Thanks very much, Brett, and appreciate everyone's time for joining today. This is Janus' 5th year in operation, and there's a bit of a video here of some of the different truck models that we've done. Probably the most two prominent ones for the mining industry is a trial that we did with BHP and Cube in South Australia, running a triple road train with a battery swap from the Carrotsine mine down to the Whyalla port at about 150 tonnes. And the next one we've got is working in Bunbury with coaxial road train trailers coming into the Bunbury port. The real probably get better. Sorry, take the video off. Thanks for that. Next slide. Is that better now, guys?
Yes, it is.
Yep.
We'll make this presentation available for everyone after I'd say it was the video that was causing a little bit of an issue. When you look at the Janus business model, there's two parts to the Janus process. There's our assembly and manufacturing, where we create the conversion module for the existing fleet, where we take the diesel engine out of the vehicle. We replace it with essentially an electric and transmission crate module that goes directly into the truck where the diesel engine comes out from. We remove the fuel tanks and exhaust system. We replace it with our swappable battery technology. We also have an integrated charging system so that you have a battery swap that occurs as part of it. And then we have our software platform that sits over the top of all of this that manages all of the transactions. So the second part is our ecosystem, which is the software platform. It's managing all of the gridding inputs, charging, charger utilisation, battery utilisation, and truck data, so that you get a complete visibility of the fleet's energy usages, requirements, and utilisation of all of the assets within the pool. It also provides all the tracking and safety data as well too, and real-time monitoring of all of the assets that are operational in the pool. The key to this is with the battery swap, obviously we can stage the charging when it makes sense for the grid, so that you can optimise pricing windows within the grid for recharging the batteries. Just to give you a bit of an overview of the journey so far, 23 trucks have been converted. We've put roughly nearly 630,000 kilowatt hours through our charging network. We're in excess, these numbers are current as of the 31st of January. We're now at around 2,500 battery swaps through the network and a little over 330,000 kilometres travelled. The picture you can see below is obviously the triple combination that we had operating for Cube and BHP in South Australia, carrying copper concentrate. Just to give you a bit of an overview, the conversion cost is a base cost of around $175,000. Depending on the spec and the rating in the truck, it's from $175,000 to $225,000. That doesn't include the battery set. The battery sets are on top of the conversion price, and we've got pricing for those, or you can simply rent the batteries on a batteries as a service model. The key difference with Janus with the swappable batteries, it's a 4-minute swap to swap 620 kilowatt hours, as opposed up to 3 hours with the existing prime movers that are in the recharging network at the moment, such as the Volvo prime mover. Again, just explaining, the JCM is the Janus conversion module. It goes directly into the front of the truck where the diesel engine comes out of. There's a new radiator package. So if you think about it's a complete overhaul kit for the diesel engine and transmission that goes into the front of the truck. All the ancillary services such as air compressor, power steering pumps, air conditioning, all of that becomes electrified, and that is it's essentially a new heart for the truck removing the total diesel system out of the truck. Our Janus side batteries, there is 2 side batteries, so we call them a side module. It takes 2 side modules to make a battery. Our battery pack is a total of 620 kilowatt hours. Our next generation that is coming is 650 kilowatt hours. It's a sodium-ion battery. We're aiming to have prototypes of them available at the end of June. They are a 650 kilowatt battery pack. Will allow us to operate up to 70 degrees C, so it brings in all of the Pilbara operations for the battery to be an air-cooled battery without having to introduce liquid cooling. And we're looking at a 20-year battery life for that product. So there's some major changes coming in our battery technology. The next generation after the first 650 will be a megawatt pack. So it will start to extend ranges quite more significantly than where we are today. We're aiming to have that in about the next 12 months. Yeah, Nick, you've got a question? Can't hear from Nick, so Brett, will you unmute him if he's got a question, or if not, I'll continue on.
If you've got any questions, type them in the Q&A, and I can unmute you if we need.
Okay, great. The other piece of the technology that's been developed is what we call our Janus charge and change stations. These are simply a 20-foot shipping container with the charging infrastructure located in it. What we do is we can deploy them onto site. They need a 300 amp feed. It's about 3 hours once the charge station is deployed on site. So Nick's question is, what sort of cost difference in the batteries? So yeah, currently our battery sets are 250,000. With the new sodium ion, they'll be going up to around 350. Will be the price. So we'll be able to share that data. Once the first prototype arrives, we'll have a commercial price on the sodium ion. Just to give you a bit of an overview of the software platform, this is the dashboard that the fleet operator sees. At the moment, we've got it showing a battery, the internals of a battery, but you can see where we've got trucks operating throughout Australia and batteries operating. The key difference of this is where it gives great performance analysis of what the assets are doing. It also gives good safety levels. We're looking at battery levels and also optimization of the infrastructure. So what sort of duty cycle are you getting out of your trucks in real time? When will you need energy? When is there energy available? When will you be wanting to swap a battery? What the grid's doing at the time in the generation area where the charge station may be connected, and bringing all of that information into one dashboard so that good decisions can be made around charging. Obviously, a lot of this is automated, but it gives you complete visibility of it. The other side of it is obviously optimization of charging, fleet performance, real-time tracking of your assets, and also the integration with the market, depending on what grid you're located in, or whether or not you're utilising renewables in a behind-the-meter solution as well too. These are some of the real-world ranges that we've got with our current existing battery technology at 620 kilowatt hours. So from your super quad and your triple road train, somewhere between 4.5 to 3.5 kilowatt hours to 4.5 kilowatt hours per kilometre. The biggest challenge is these are real world, so you've got to take into account the topography of where you're operating, what the level of regen you're getting in certain applications. The biggest things that we find that affect range on vehicles, obviously wind resistance. When you're in a high speed application, so if you're doing your 80 and 90 kilometre hour average speeds or top speeds, that's where you get a lot of impact on your range, and obviously headwinds play a factor as well too. One of the unique things around it is, and what we've seen in some of the metropolitan applications, the energy consumption is very similar every day for trucks doing the same freight task. So it's very easy to get a really good accuracy on what energy requirements are needed. We're seeing variations of less than 3% in kilowatt hours used per day on the same freight task, which is very interesting, no matter what truck it's in that application. So it's good from a point of view being able to understand what your energy requirements are in real time. These are some of the commercial pieces that we have for metropolitan fleet operations. Cost of charges, cost of battery sets and conversions, and the warranty packages that are available. We do charge usage and subscription fees for monitoring and for ongoing support. We run a 24-hour support. You don't need to bring your truck back to a dealership to get an upgrade or new code updated to it. All of that happens over the air. And what we're doing is constantly improving energy efficiency and utilisation of the asset. As we're collecting this data in real time, we're analysing and we're making small changes, which we then roll out in code updates out to the vehicles based on driver feedback, but also on data that we're collecting on a daily basis out of the assets. So the whole essence behind our system is how do we get you more performance out of the assets that you have deployed in field. As mentioned, we also have a capital light model as well too, where you can hire the battery assets or the charging infrastructure from Janus, and we provide it on a kilowatt hour basis and a daily hire fee in a 24-hour period. But obviously we can delve into that further, or if you'd like to talk to us about that offline, we can tailor something and model something for a freight task that you may have operational. As part of our in-service management, we're obviously doing driver training. We have an authorised dealer network across Australia for repairs, and we will be opening a conversion facility in WA, in Perth, to look after the WA market. We already have a conversion dealer in South Australia. Currently, Victoria, New South Wales and Queensland are being done by ourselves here in Berkeley Vale on the Central Coast. The WA dealer will be located in Perth, and conversions will be happening by mid to late third quarter of this year. And again, there's also the Janus 24-hour support, also supporting the assets in the background as well. Janus is also embarked.
So we had a question there around the authentication fee, what that is? Sorry,
what was that? The authentication fee?
Yeah.
Yeah, so that is basically the battery health report, and when the battery is swapped, it covers the swap of the battery and the authentication of the battery between the assets. So that happens when you swap the battery. It basically certifies that the battery's got a health check that's been performed at the end of its charge cycle, and it's for the provision of the forklift on site to do the swap of the battery. Under what we've got at the moment with ARENA under the Driving the Nations program is what we call the Green Corridor project. These are some of the sites and locations. Obviously, the orange is the existing Janus charge and change infrastructure. The green is the additional. We have two parts to this. One is with the current NMC technology, and then the next site is with sodium-ion, and where Janus is going over the next. This is a 2 to 3 year roadmap of where Janus is going. So, if there is interest of that, we are taking expressions of interest from fleets to participate in the program. What we're looking at doing is getting matched funding for the conversion of the vehicle for the operator under the Driving the Nations program, which will be about a 50% match funding for the conversion of a vehicle. All of the Janus product is available in the NCAP safety app. This is for first responders and for emergency services, all available online. And if you have got the NCAP app, have a look at the Janus. You can see the Janus models that are live on the app. Obviously, the benefits for fleets. There's a clear value proposition for the operators in a short payback. Reduced operating costs, reduced service and maintenance costs. Depending on where you source your energy from, it also meets your greenhouse emissions targets a lot sooner. Obviously, it's very challenging at the moment with the current OEMs products. To meet those targets, we needed to start last year with 100% production of trucks in Australia as zero emissions. It's simply just not possible with new products. So conversion of existing is one way to help speed up that process and meet those targets sooner. I know with the reporting that's coming with scope 1, 2 and 3 emissions that are being compulsory reporting with ASIC, shortly a lot of that is seeing pressure from fleets to make this change, and how they do that at quantity and scale is challenging with the existing OEM product and the limitations on gross combination mass. So currently our vehicles, if you bring us a truck that's a 225 tonne rated truck, it will come back to you as a 225 tonne rated truck. There's a question there around torque. We're 2,500 Newton meters of torque from dead stall. Your gradability and startability is matched because we use a transmission. We're not just using a direct drive electric motor. We do have a transmission that goes through that, goes through the existing drivetrain, utilising the diff ratios that will meet that requirement for gradability and startability. There's just a bit of an overview there of what the current electrification solutions that are out there in a comparison to hydrogen and diesel. We don't think hydrogen is going to have any part in the future in road transport. Just the efficiencies of it aren't there from an energy point of view, and the capital cost is quite significant. We do believe the battery swap is the better way to go. I know we're a little bit biased around this, but I come from the transport industry, and I haven't found a solution out there that makes it work in a reasonable way and that is scalable currently at the moment with the existing technology parameters. The key difference about Janus is our battery technology. We're agnostic to cell chemistry. So we don't, there is a lot of advancements coming in battery cell chemistry technology, which will see greater ranges and energy densities provided in the pack. So our form factor, we're agnostic to what cells that we put in it, provided it meets our safety criteria and it also meets the economic value proposition. We look to transition with that technology as it becomes available in new cell chemistry. These are current existing EV trucks that are available in the market today. You can see from a capital cost point of view and charging piece, as well as ranges. One of the things that we haven't got on here is gross combination mass, but pretty much everything that is available from the OEMs is limited to single trailer operation at a 44-tonne gross combination mass at this stage for road-going operations. Windrows is potentially going to be up to around 68 tonnes, so you may get to a B-double application at this point. We've done our first solar power charge station here in New South Wales. It's at the Moorebank Logistics Park, where the entire charge station is powered from rooftop solar. And the battery swapping is what makes that possible, because we're able to have batteries there to be able to take energy at the time when the solar is in production. These are just some of our existing customers that are currently utilising the Janus system. Cube, particularly in WA, Simmons Clark in South Australia, and then we've got Cement Australia working in New South Wales and Victoria, and obviously the logging application in Mount Gambier with multiple trailer combinations. Feedback from the logging operator is they don't have to put the diff locks in the truck. They're working in the forest because of the smooth delivery and the ability of the driver to have very good control with torque application with their foot. They're not finding that they're getting any bogging issues or slipping because of that superior torque. The superior torque there at low speed and low RPM. It's that initial availability of torque and control that you've got in comparison to a diesel. It is very it's made a big change for them. No, there's a question here from Greg around impediments with the change of government, Arena Green Road covered off on that possibility. I don't see there's any, we don't see any impediments at the moment at this stage with Arena. Apart from that, it'll be slow. Just trying to answer these other questions here. We've got steep inclines. Yes, we've got these trucks working in 10 and 12% gradients in applications. Typically, most of the average stuff they're working in is around 6 to 8%. Load capacity, tear weight of the vehicle goes up by about 2 tonnes, but under the federal policy and the state policies with zero-emission vehicles, we're getting 7.5 tonne on the steer axle and 18 tonne on the drive, typically operating in HML routes or high mass limits routes, and on route-specific corridors, they're opening them up. So part of the process is understanding your freight task and your logistics task and putting that into the National Heavy Vehicle Regulator portal, and they will give you an approval on a zero-emissions vehicle for a route-specific increase in payload. In Cement Australia's example, they're 500 kilos better off in payload in comparison to the diesel because of this the 8 and 18 tonne policy. We've asked the National Heavy Vehicle Regulator to be a little bit flexible about where that weight is, in that we can go from, instead of 8 tonne on the steer, go to 7.5 and move the half tonne back to the drive so that it can float between axle groupings. What sort of cost difference? Hang on, just trying to get everyone's questions here. Are there any questions that I've missed there? I think I've answered the 4, but I've seen some other ones pop up, Brett.
There's a couple on the chat box. One around the conversion to sodium-ion batteries having impact on vehicle payload.
No, the sodium-ion is a like-for-like. The interesting thing around the technology that we've sourced is we're going from a 230 watt-hour per kilo NMC cell to a 450 watt-hour per kilo. So we're seeing more usable energy. It'll be a like-for-like at the moment because we're increasing the usable energy available to the truck. Our next generation, so our Gen 2 sodium-ion, we should see, we're trying to achieve roughly about a 500 kilo weight saving in the existing packs in comparison. Yeah, so regen capability, trucks have full regen, so they've got full torque, so it's 2,500 Newton meters of torque in regen. Obviously, that can be limited by battery capacity. Essentially, that comes back to we don't put a charge station over the top of a hill. It's interesting in some of the applications. In one application of Bunbury, we're seeing regen numbers in excess of 60% because we're coming loaded back down into Bunbury from the mine site. In metropolitan applications, we're seeing 30 to 50% regen depending on driver behaviour. In the logging applications, around 25 to 30%. It's in Mount Gambier where there's not many traffic lights and not a lot of traffic, so you're not seeing that as you're not getting a lot of regen opportunities in this, and a lot of it's highway operations. So anything where you've got a long haulage task, you're going to see regen numbers around 20 to 25% coming back in. No, the sodium-ion battery is not cheaper at this stage because it's not at mass scale production. I believe it will become cost comparable to existing lithium technologies as it gets into scaled manufacture. And there is less. Yeah, there is a huge safety benefit with sodium-ion with thermal runaway. There is no. I've been and witnessed nail penetration tests. Butane torch test, 20 minutes of a butane torch on a pouch cell and no thermal nail penetration test on multiple sequences. There is just no chance of thermal runaway. It's interesting the chemistry that's in that pack. It's not the Prussian blue chemistry that's in there, which has been deemed as a Class 8 battery. This generation of sodium-ion doesn't use that technology and technically is a non-hazardous battery. So there's some work being done there to change the categorisation of the sodium-ion pack. Look, there's not a lot. You've got about 3 sodium-ion pack manufacturers out there in the world at the moment. There's 2 of them I wouldn't touch, and the other one we have the exclusive rights for. So you're talking to that person at the moment if you're looking to go down a sodium-ion in a form factor. Ambient temperatures. One of the reasons we're transitioning to sodium-ion is because of that higher ambient temperature. In our current discharge form factor, we have a limitation of about 50 degrees in ambient, so we're not comfortable with that going into the arid locations or into the Pilbara, for example, with NMC. Sodium-ion, we have an operating temperature up to 70 degrees, and due to the low C rate, our average discharge is about 0.6 C in road train and triple operations. So we have a very low discharge rate on the battery. The battery is actually rated to a 5 C constant discharge and an 80 C 20-second burst. We'll probably see a 2 to 3 degree pack rise over ambient with the sodium ion. So that's one of the reasons that we're transitioning to it. The limitation on sodium is at about minus 30 degrees Celsius. You start to see a sluggish performance, so they have a really wide operating temperature range. Another one, can you comment on any of the challenges in installing charging stations? Yeah, look, there is obviously the limitations of grid. One of the unique solutions that we've overcome is by being able to control when we charge and swap. You can actually look at sites where you may be utilising a power connection for 10 hours of the day, and then look at being able to charge after hours. There is some limitations in certain parts of the grid, but typically we've been able to find a 300 amp feed reasonably well in certain locations. But I'd encourage you, if you've got the opportunity to do behind the meter with rooftop solar, and stay out of the grid, it makes it a lot simpler. And obviously you're getting the benefits of not having distribution costs in your power component as well too.
Under the Q&A tab, there was a question around who builds the battery packs. Do you do that in-house?
Yeah, so currently we're building the battery packs in-house. We're in the process of going out to contract manufacturing for our battery, and it'll turn up as a finished pack to meet. We're trying to scale our production line. So one of the things that we'll be outsourcing under license is the production of our battery pack in our existing form factor, and that will be happening with our existing we've got 2 suppliers at the moment that we're working with on pack manufacture.
A question come through. Haven't heard you mention LFP battery chemistry. I would have thought this is a low cost compared to sodium ion.
Yeah, look, LFP is last year's generation. Like, LFP is the yesterday technology. Unfortunately, you don't see LFP with 450 watt hours per kilo energy density. Look, a lot of people are using LFP, and that is historic because of that was the main chemistry that has been produced. We used LFP in our first battery. We struggled to get the energy density and range required, and hence the transition to NMC. Look, the jury's still out on LFP. The thermal risk's still there with LFP. People say there's no thermal risk with LFP. That's incorrect. There's just as much. Cell life and cell cycle life. I don't think we've seen enough detail yet and enough real-world application of LFP to say that some of the technology they're saying is out there at 10,000 to 14,000 cycle lives. They're not being achieved yet, as we've seen in the market. So we're moving away from LFP because we think it's the old technology piece. We're moving to that higher energy density because a lot of the applications are chasing range, and obviously with a LFP, you get when you have high discharge and charge, you really reduce your cell life of that battery. Whereas with sodium ion at 5C, you really extend the life of the battery. And early estimates, we're going to see cell life out to 20 to 25 years in the battery pack. So that gives you a really good asset for utilisation, and you just don't get the degradation of the cell with sodium ion either. They're a very hardy cell. So if you think about secondary application and static storage, that's what that battery pack will be for.
Question now around increasing the number of conversions that occur each week, because I can see that you're sort of growing, and what's your capacity for that?
Yeah, so one of the reasons we're going to the dealer model, and also we're moving the factory this month or March. We start moving to a larger scale facility that will allow us to scale production, and that's one of the reasons we're outsourcing our battery manufacturer as well too, is so that we can scale production. We're looking to try and grow our numbers quite significantly. The roadmap over the next 3 years is to get us out to 1,000 trucks a year out of our existing plant, which should meet the Australian market quite comfortably, and a small part of the export market as well too. So that's a staged rollout over the next 3 years, so that we start to do that, and also dealer networks being able to do conversions in state, so we're not having to truck trucks across the country at the moment to do conversions. That's why the South Australia and Western Australian dealers will become very pivotal in installing the kit, because it's the same kit that we put in a Volvo, a Mack, a Kenworth, a Western Star.
So, question pop up. There's lots coming through, but 1,000 trucks a year, like what's sort of the capital required to be able to do that, to ramp up to those numbers?
Oh, look, there's a lot of means with that capital, where the battery fund, those sorts of things will be needed as we grow to meet those capacities and forward orders. So the modelling is there, but I'm not here to answer financial questions in this meeting. Happy to share that offline and talk through that with people if they need to outside of the meeting. But sounds like an investment question.
Yeah, no, I'm just trying to catch up on what's been covered and what hasn't. But
typical depth of discharge. So currently with NMC technology, you look at about an 80% availability of depth of discharge. Sodium ion, we're looking at about a 90%. NMC, you charge to about 90%, 92% capacity of the cell, but you have a real shallow depth of discharge. Sodium ion, we have a greater depth of discharge. The voltage range on a sodium ion runs from 4.2 down to 1.1 volts in a cell, so it allows you to have a greater depth of discharge and usable kilowatt hours out of the pack.
Question from was it Stephen, about asking to elaborate on the swappable tech that has been patented?
Yep. So the battery, our form factor, and the process in swapping the battery is what we have patented. It's the system and the process in what that's done. So there's patents on our battery form factor, our swappable solution, and the business model with the ecosystem and authentication, and also on the conversion module.
Okay. And
we do have plans to automate the forklifts. We're looking at some automated 2.5 tonne forklifts. And then as we scale into large charge station facilities, it'll be warehouse stacking cranes where the vehicle will just drive underneath, and essentially, we'll get that battery swapped down to a sub a minute in large scale operation. But that's a little way down the track. One of the biggest challenge with large scale, to make that work, you've got to have a very big power connection. So we're looking at how do we optimise that, and the first part of that automation will be a 2.5 tonne forklift. Currently, all the drivers are swapping their own batteries at the current existing charge stations. I think what difficulties might arise when switching. There's no real major difficulties in swapping battery chemistry, because it's essentially the battery cell is just an energy storage unit. What we do is we pair that with our BMS, and obviously load the cell parameters into the BMS, and the BMS monitors that. So if you look at the way to draw a comparison to it is, currently you've got diesel that's manufactured to a standard that allows multiple OEMs to use that as an energy source to power a vehicle. What we've created with Janus is a energy storage receptacle in a form factor that can fit on multiple OEMs platforms, that is agnostic to what the source or the storage is of the energy, so the battery cell. So inside our form factor, currently at the moment, is 525 battery cells on each side, so 1,050 cells. The 175 cells in a pack in series, 3 packs in a side module, 6 packs between the 2 units that communicate to the truck. If we have an issue in a cell, the pack will isolate, but the truck still has 5 packs to operate on. That allows the truck to get essentially down to about 3 packs is where we see a complete with into limp mode. But we haven't had anywhere near that. We haven't had that. We've never had a walk home event in our vehicles.
I think we've covered just about all the questions. Anyone else got any last questions that haven't been covered? There's one, have you experienced any thermal issues, faults in battery in your BMS during the trials in WA or elsewhere?
No, we haven't had any. We haven't had any issues in vehicles that are in trials in WA. We did have. I think it's pretty public knowledge that we did have a thermal incident back in 2023 with a battery that we had catch on fire. That did happen. What we've learned from that, and we basically brought we've done a full battery recall, root cause analysis. We had a cell go into thermal runaway with an internal short. What we did have from that, the learnings from that incident, 3 weeks prior to that battery incident, the cell change parameters in data that we collect. So we've got about 35,000 cells out there at the moment currently in field that we take millisecond data up into the cloud that we analyse. We saw a change in behaviour in that cell 3 weeks prior to the incident. Was not a behaviour that we'd seen before in our data sets. And so what we currently do is we are running an algorithm, what we call a cell degradation indicator, that runs across looking for key data sets that change on any cells that are in operation. It's also led to a major change in the construction of the battery and production procedures, as well as additional G-shock sensors being put into batteries, hydrogen off-gassing, temperature monitoring, increased fusing across high voltage harnesses and low voltage harnesses, harness design change, and that's something that we've done, and we've the last 12 months has been that, and hence why our numbers haven't rapidly grown in trucks, but we're back into production now with our trucks and trucks back on road. Do we need tyres to upgrade? Do we need to upgrade tyres? No. It's interesting, Cement Australia are doing a trial at the moment with Goodyear in a low rolling resistance EV spec tyre. One of the interesting things they're finding is that the tyres seem to be performing much better than their existing diesel trucks because of the smoother delivery of torque and particular steer tyre wear. A lot of the North American trucks have an irregular steer tyre pattern that happens typically on the right-hand side steer tyre, and that's because you're getting a preloading of heat from the turbo straight onto that steer tyre, and you get an irregular wear. Kenworth is very bad for it. That's been eliminated completely from the Cement Australia fleet that has been operating on this solution, and it's attributed to direct heat loading, and particularly with chassis-mounted exhaust. A lot of the comments and feedbacks from drivers is the cabs are nowhere near as hot. You're not with emissions controls. You've got exhaust temperatures running there at nearly 700 degrees. All that heat's out from underneath the vehicle. So we're seeing an extension in componentry life. The air conditioner is performing massively better than what a diesel truck performs, and to a point where some of our sleeper cabs, they don't need to run a diesel power pack or an ice pack as such for cooling the cabs for driver resting. They can just run the aircon of the truck. Do I see the solution expanding into heavy mine haulage? Depending on what you mean there, we're looking at battery electric road train. So up to 240 tonne payload, we'll be releasing a product that will cater for that. And with a battery swap technology, that's something that we're working on, a BERT project as it's called. We will see that in longer distance operations where your mine or your resource body is sitting, where you've got to bring it back to a processing pit or to a rail loop. Yes, we see this expanding into that. We're working with an Indonesian coal miner at the moment on road train, 250 tonne payload road trains, carting coal from a pit to port. There's a 250 truck operation that we hope to be able to expand on there very shortly with conversions of that existing fleet. Yes, we do provide training services to educate operators, and we also provide training for conversion. All of that happens. We provided a number of different formats. Our factory is an open door policy. We're happy to let people through if they're a customer. or they're a client with a serious interest, we open the doors and bring people through. We train technicians, we train fleet operators. We also open it to customers to come through and our clients' customers as well, so that everyone gets a very good understanding of the technology. I'm following the questions in the chat. I don't think there's any other ones in the Q&A at all.
No, I think you've you've got them all. Been covering a lot, so.
Part of the service that we do offer as well is modelling and freight tasks, so that if you're looking at a particular haulage task, we'll help with some modelling on energy usage, charging infrastructure required, and operating requirements. Also happy to do tripartite, where if it's a mining company that has existing fleet operators, that we work together to solve the problem, or work on a solution in conjunction with the fleet operator as well. It's something that we offer as a part of the process of what we do as well. We haven't got any locations on the Hume Highway at this stage. We're currently charge stations. There's 9 deployed around the country, 2 in New South Wales, 2 in Victoria, 2 in South Australia, 1 in WA, 1 in Queensland, and there's multiple charging points in Victoria. So a couple of our charge stations then there are 3 charges at a site due to volume. At this point, we're not opening the highways immediately until we bring sodium-ion in, as we're going to see an increase in range. What we don't want to do is build infrastructure that may become defunct because of battery ranges increasing, because we know what the pipeline is for battery cell technology that's coming. We've just been more focused on back-to-base operations. Obviously, under the National Green Corridor project, that will take close to 10 to 12 months to go through ARENA, and that will see more charging infrastructure open on highways so that we can start to electrify some of the major routes. Do I think we'll electrify the Nullarbor? Not anytime soon, due to the distances and lack of infrastructure and lack of traffic volume. We sort of look at it in an approach of, where does it make sense to do it economically and environmentally? At the moment is where we focus our targets.
Okay. I think that's everything. Thanks everyone for your time, and thanks Lex for presenting and answering all those questions. Like a lot to digest there.
There's one other question that just came through there. How much space does each swap and charge station require? Currently, at the moment, it can fit into about 1,000 square metres, depending on where you locate the charge station. What we can do is we've got a schematic there that we can send through to you, Nick, on charging infrastructure. If you'd like, we can send that through to you, which is readily available for a single bay charge station or a quad bay charge station, which will give footprint layout and power requirements for the site. But currently the charge station fits in a 20-foot shipping container, and you need about a 10 metre by 10 metre pad around the truck to be able to perform the battery swap on a nice level concrete pad. So.
Oh, I think we might call it there. Oh.
No problems at all. Thank you very much, everyone. Really appreciate the opportunity to present. And if you want more information, feel free to reach out.
Yep. So thanks, Lex, for presenting again. That was great. Seems like there's big future for the battery swap. It makes a lot of sense, and how it's interchangeable, and so good luck with it in growth.
Yep.
We've got a couple more webinars coming up in March. One around mining processing and around simulation for decarb. So tune into that, register those if you're interested on, through LinkedIn. But other than that, I'll just, I'll quick shout out to Mevco of help supporters put on some of these webinars. So, thanks for that to Mevco and the team. Anyone, we're always open to other support to help these, make these sustainable. So reach out if you're interested. But thanks everyone. Thanks Lex, and see you next time. Cheers.
Thank you. Have a good day. Thanks everyone.